Lesson 1.1, Modeling and Equation Solving. The one standard we are going to discuss, create equations in two or more variables to represent relationships between quantities. We have many different ways we can represent information in mathematics. Okay, so we're going to discuss 4 different models that we can use. The first one is very generic, the mathematical model. That is simply a way to represent data so that we can predict future information from that data. The next is a numeric model. Numeric models are basically tables of values. Okay, so we have our X, our input, our Y, our output, creating that table so that we can find and pinpoint certain pieces of information. Algebraic models, the ones we probably use most often, that's where we're creating equations with variables to represent unknown values. And then the last one, the graphical model, using our graphing utilities in order to graph more complicated functions so that we can find the x-intercepts, the zeros, or intersections of two graphs. In this first example, we have a very basic situation. A pizzeria sells a rectangular 20-inch by 22-inch pizza for the same price as its large round pizza, which has a 24-inch diameter. If both pizzas are the same thickness, which option gives the most pizza for the money? Okay, so we want to determine which one is the better deal for us. First equation we can set up is one that calculates the area of a rectangle. If we have 20 inches times 22 inches, that's going to give us the area for that rectangular pizza, which is going to be equal to 440 square inches. Now if we want to calculate the area of a round pizza, the area of a circle is pi r squared. We have the diameter, which is 24, so if we substitute the known radius, which would be half of that, 12, in there we have pi times 12 squared. Pi times 144 is going to be approximately, not equal to, approximately 452.39 inches squared. So since these are the same price, this one, the second pizza, provides us with more area. We get more pizza. The round pizza would be the better deal. This next property you should be very familiar with by now, the zero factor property, also known as the zero product property. This tells us that a product of real numbers is zero if and only if at least one of the factors in the product is zero. We see this when we're factoring out quadratic equations. If I had x squared minus 10x, and then let's just go with plus 16, and I set that equal to 0. Well, we can factor this quadratic down. This would factor into x minus 8 times x minus 2. Now the zero product property applies. We have two factors being multiplied together, and the product is equal to 0. So that implies that one of these factors, at least one of them, has to be equal to 0. At this point, we would set each factor equal to 0 to find those two x values that make that product equal to 0. In this next example, we want to solve the equation x squared equals 8 minus 4x algebraically. First thing, if we're going to solve this algebraically, we need to set it equal to 0. So I would subtract 8 to the other side and add 4x to the other side, giving us the equation x squared plus 4x minus 8 equal to 0. At this point, we could try to factor this, but as it turns out, this does not factor down nicely. So we can use the process of completing the square, or we could use the quadratic formula, or we could graph this to find what those x values are. Since you all love completing the square so much, we'll go through that method again. Our coefficient is 1. Now we just need to move our constant to the other side. That means we have x squared plus 4x equal to 8. Now we need to add a value to both sides of the equation. We take b divided by 2 and square that quantity. So we add 4 divided by 2, which is just 2. And we're squaring that quantity, which means we have to add that to the other side as well. So I took my b value, which was 4, and divided that by 2, and simplified. That's where we got this 2 from. Now on the left side, since we added that b over 2 quantity squared, that creates a perfect square trinomial. So this will factor down into x plus, since our sign was plus, we know this is going to be plus our b over 2 value, which is 2. So simplified to x plus 2 quantity squared equal to 8 plus 2 squared is 4. That would be 12. Now we solve, take the square root of each side. X plus 2 is equal to plus or minus radical 12. And that will simplify down to 2 radical 3. So the last step, subtract 2 to the other side. We get x is equal to negative 2 plus or minus radical 12 simplifies down to 2 times radical 3. If you would use the quadratic formula, you would come up with the same solutions. If you would graph and find these x-intercepts, the zeros, you would get the decimal approximation of these two values. The main focus of this lesson is to relate concepts to each other that have the same basic meaning. Okay, so the fundamental connection, if a is a real number that solves the equation f of x equals 0, then these three statements are all equivalent to each other. So the first statement is the number a is a root or solution of the equation f of x equals 0. Second statement, the number a is a 0 of y equals f of x. And the third statement, the number a is an x-intercept of the graph of y equals f of x. Sometimes the point a comma 0 is referred to as an x-intercept. So when you hear any of those four terms, root, solution, 0, or x-intercept, it's all referring to the same basic idea. That's why in the last lesson, when we were using the graphing calculators to find the x-intercepts of the graph, when you go through that process, there isn't a button to click on for x-intercept. You click on the 0 button. You're finding the zeros of the function, which are the same as the x-intercepts. They all mean the same thing. You've discussed this in the past, so we're quickly just going to review George Polya's 4 problem-solving steps. The first step is to understand the problem, take all your information, determine your knowns, your unknowns, and truly understand what it is you're trying to find or calculate in the problem. The second step is to devise a plan. Okay, for most of what we're doing, that's going to be create an equation from your knowns and your unknowns, find or determine which variables you're going to use to represent the quantities you want to find. Okay, so set up your equation. Third step, carry out the plan. Solve your equation, get an answer, and then step 4, look at what you got, the answer you got from step 3, and determine whether or not that makes sense in terms of the problem you're given. If you were calculating how much money you made per week at a 40-hour-a-week job, and you came up with an answer of $4, okay, you probably made a mistake somewhere, or you want to find a new job. Okay, so these are the 4 basic steps to problem solving. The last thing we are going to discuss in this lesson is taking a look at some flaws with graphing calculators. So in this example, we're going to look at the graph of y equals 3 divided by the quantity 2x minus 5 on a graphing calculator, and we want to determine whether or not there is an x-intercept. Okay. The problem you're going to run into is if you're using an older version of a TI-83 or a TI-84. If you're using newer versions, I think you'll be alright. So if we look at the screen on the left side here, this would be the graph of the equation. If you type this in, this is similar to what you would see. Some of you are going to see this vertical line, others will not. This vertical line represents the vertical asymptote for this function. It's actually not a part of the graph of y equals 3 divided by 2x minus 5 at all. So when we're looking, trying to determine if there's an x-intercept, at this point where it crosses the x-axis, this is not a part of our function, so this is not an x-intercept. This is simply the line for the vertical asymptote for this function. If we look at the table on the right, we have some input values, very close to 2.5, and we have the output values. If we look when x is equal to 2.5, we do not have a y value. Okay, so that point does not exist. So if there isn't a y value at 0, there cannot be an x-intercept. So that's one thing to be aware of when you're using these graphing calculators. And another thing, we could look at our equation and solve this algebraically. If we would put 2.5 in for x, 2 times 2.5 is 5. 5 minus 5, we would get 0 in the denominator of the fraction. That is why there is a vertical asymptote at that location. This will be more applicable when we're dealing with rational functions. That's why you need a solid algebraic understanding of this equation, realizing what value of x makes the denominator 0. That way you can better understand what is happening with your graph and all the parts of your graph. Just a quick review, the main things you need to remember from this lesson are the relationship between these four terms: root, solution, 0, and x-intercept, all referring to the same concept. And you also need to make sure you have an understanding of these 4 steps. The main step, number 4, when you're dealing with story problems, you get in a habit of whatever answer you end up with must be true. We need to do a better job of checking to make sure our answers are reasonable in terms of the problem we're dealing with.